Okay, so the next question I was asked for was 2010. Again, question 1. Again, I'm going to leave the calculation for a separate video. So question 1, part A, you're asked give the full name of EDTA, ethylene diamine tetraacetic acid. Okay, name an indicator for this titration, so hard water. So again, we're back to ureachrome black tea or solachrome black tea, doesn't matter which one you write. And state the colour change, so wine red to blue. Okay. Next question then, you're asked what is the general purpose of the buffer. So always a buffer resists changes in pH, and that has to be very accurate there. Okay. Then you're asked what buffer was required, pH 10. And finally then, what problem would have been encountered in this titration if the wrong buffer was used? Remember, the buffer of pH 10 is used because it's the pH at which the indicator works best at. So you'd end up with an inaccurate endpoint, okay? Because it's not the pH at which my indicator works best at, okay? Part D then, explain the two operations involving the titration flask and its contents carried out as the EDTA was being added. I'm not going to go and write this down. Swirl the flask and wash down the sides with the ionized water. That's just your general glassware stuff. Okay, part E I'll come back to later. And then state and explain whether the laboratory, whether water having passed through the deionizer is suitable for use. No, it's not suitable, and the reason why, and we'll look at it in question part E, is that I still have water hardness left. Okay, so there's still ions that contain water hardness present. My pen is after going. Okay, so ions that contain water hardness present. Okay, so that's the reason for that there. So ions that contain water hardness are still present.